So with that, we're going to transition over into talking about the specifics of how do you actually start to get involved in some of these things. So we're really lucky to have Jang Condell from NASA headquarters here, who's going to give us the latest and greatest update on what you can do with NASA at the moment. So take it away, Hannah.
Not this one. Let me see. Okay, all right. Good afternoon, everyone. I'm very pleased to be here. My name is Jang Condell, and I work at NASA headquarters. My title is Program Scientist, and I'm here to tell you about, just give you a brief introduction to what NASA does in terms of astrophysics, and talk about opportunities to engage. I'm not here to talk about budget stuff. That is an ongoing process that is in the hands of Congress right now, and it would be inappropriate for me to comment on that. But I can tell you sort of the nitty gritty, like how can I get engaged? How can I, what opportunities are there for me? I'm going to start with a little bit of an introduction about me. I was asked to give a little bit of my career trajectory in getting to where I am. Okay, so I have a 3-degree background, bachelor's, master's, and PhD. I graduated with my PhD in 2004, so that tells you a little bit about just how old I am. I did 3 postdocs, the Carnegie Fellowship at the Carnegie Institution for Science. So this is not the Carnegie Observatories. This is the one in Washington, D.C. At the time, it was called DTM. It's now called the Earth and Planets Lab. I was then a Michelson Fellow. I was the last Michelson Fellow. It then became the Sagan program. And I took that fellowship to the University of Maryland and NASA Goddard Space Flight Center. And if you look at those years in there, and this is where I want to touch on a little bit about the resiliency. What happened in 2009, 2010? Who remembers or knows your history well enough? That was the Great Recession, like the housing crisis. Everything plummeted. In 2009, 2010, every single faculty job was canceled. There were like no jobs to be had. And so part of the reason I ended up doing that 1-year postdoc at Space Telescope Science Institute was because I struck out completely applying for faculty jobs. I was about to leave the field. But then a friend of mine who's a few years ahead of me in career-wise, who had a position at Space Telescope, said, you know, I got a year of funding. Why don't you come work with me at Space Telescope? And, you know, I can at least keep you going for another year. And I said, okay, great. And so that year, I stuck around, stuck it out for another year, applied, and got a faculty position out of that. So there's 2 things there. One, networking. Networking is super important. Doesn't matter. You don't have to talk to all the bigwigs in the room. Talk to people your age. The person I talked to was just a couple years ahead of me, career-wise. We met when I was a student. She was a postdoc, right? So the connections you make within this very room will pay off in the end. The other thing is persistence, which can be very hard when times are tough. But those are the 2 things I would say if you want to stay in astronomy: networking and persistence. Okay, so then after that, it was a typical academic trajectory. I taught at the University of Wyoming for a number of years, got tenure in 2017, started thinking, do I really want to stay in academia? And eventually decided I wanted to make a shift. And so I started working at NASA headquarters, and you'll notice there's an overlap in dates between University of Wyoming and coming to NASA headquarters. You can come to work at NASA headquarters as a program scientist while employed by another institution. And this is something called an IPA, which stands for Intergovernmental Personnel Act. And so I was still employed by the University of Wyoming in 2020, but I was doing the job of a NASA headquarters program scientist. And then basically at the very end of 2021, I started my as a civil servant program scientist, which means that NASA is now my employer, in January 1, basically in 2022. So that's how I got to where I am. Yes, I did start this job during the pandemic, which was also an interesting time. But that's That's a separate point. Um, about NASA. So what does it mean to be a program scientist working at NASA? And so I want to, before I get into those details, I want to talk a little bit about what NASA does in terms of scientists. And I almost put up here one of those memes that says, like, what do people think I do? What does my mom think I do? What I actually do? And what I actually do is spreadsheets, emails, and meetings. But anyway, so you all know NASA. It's the National Aeronautics and Space Administration. We put things in space, right? Um, but NASA has a number of centers. So there's Goddard Space Flight Center here in town is JPL, the Jet Propulsion Laboratory. But there's also centers across a number of states throughout the country. I work at NASA headquarters, which is in Washington, D.C. NASA also is divided up into different mission directorates. So there's a directorate for human spaceflight. They keep renaming it. I think it's ESDMD right now, which is exploration. Sorry. But it's basically there's a whole separate mission directorate. It used to be HEO, and that was easy because it was human exploration. But so there's a whole separate directorate that puts people in space. There's a separate directorate that does aeronautics. There's another one, STMD, is a space technology mission directorate. But I work in the science mission directorate. And underneath that mission directorate, there's several divisions. I'm currently in the Astrophysics division, but I've also worked in the Planetary Sciences division. And my job title is Program Scientist. So within the Science Mission Directorate, there are 5 divisions. So we have the Astrophysics division and Planetary Sciences, which I've mentioned before. The 3 other divisions are Biological and Physical Sciences, Heliophysics, and Earth Sciences, Earth Science. The next little bit of sort of structure I want to talk about within the Astrophysics division, and this is where the program analysis groups or PAGs come in. So within Astrophysics, so we love our acronyms at NASA, right? And so I've tried to expand all these abbreviations here. So when I refer to HQ or SMD and APD, hopefully you'll remember those, but I'll also try to say them out as I go through them. Okay, so within the Astrophysics division, there are 3 scientific themes. There is and program offices associated with them. So there's the Exoplanet Exploration Program, or EXEP. And so this funds things like the NEXI, this workshop you're doing here today. There's Physics of the Cosmos, which is about sort of mostly they do things like black holes and neutron stars and high energy things. And Cosmic Origins is about how things form. So how do galaxies form? How do stars form? How does the universe form? So there's a program office for EXEP here at JPL. Don Gelino right there is our program manager. And then for FISCOS and CORE, they have a shared program office at Goddard Space Flight Center. That's what GSFC stands for. Each of these program offices has a program analysis group, or PAG, associated with them. There's the ExoPAG, PhysPAG, and CoPAG. And the ExoPAG is you all. So now we're coming outside of NASA. So that gray box up there means it's within NASA, but then we're connecting to the community here through the ExoPAG. And the reason why you should get involved with the ExoPAG is because they get together, they form science interest groups. There's 2, maybe 3 active science interest groups right now. One of them is solar system and solar system exoplanet synergies, which Stephen can tell you all about, I'm sure. There's also a large number of science analysis groups. So a science interest group it's sort of a long-term group who get together to talk about issues that are of common interest. And a science analysis group typically gets together to do a specific task and do a specific analysis, and we'll write a white paper at the end, and then that will be the completion of that group. The ExoPAG meets twice a year, and one of the things they do is they see if there are findings that they want to send to NASA. And so findings can be any sort of, NASA might consider doing this, NASA might consider doing that sort of thing. So the findings are sent up are developed through consensus from the ExoPag and sent up to NASA. And I encourage you all to get involved with the ExoPag if you can. In planetary science, there's also, they also have, they call them either assessment groups or analysis groups. So in astrophysics, we have PAGs. In planetary science, we have AGs. And they're again based around various thematic themes. It's mostly about particular bodies within the solar system. So there's the MEPAG, Mars Exploration Analysis Group, the Venus Exploration Group, VEXAG, Lunar Exploration Analysis Group, LEAG. You can read all that. So that's how the AGs work in planetary science. Okay, so going back to astrophysics. So remember, we're a space agency, right? So we are the nation's civilian space agency. And that means when we're talking about science relating to space exploration, it's about both what science can you do in space as well as science about space, right? So the big thing that we do at NASA is put missions in space. And so these are the missions that are astrophysics themed, right? And so there's a whole fleet of missions. The purple ones are ones that are operating in what we call their extended operations. The green ones are in their prime mission. So whenever we put a mission in space, there's first few years are called the prime mission. So JWST is still in its prime mission for another few more years. SphereX down here is the newest mission that's been launched. So that's just entered its prime mission. The ones that are in orange are in implementation. You'll notice that Roman is here. So that's the next mission on this list about to launch. And then yellow missions as well. And so that's the outer swirl, the traditional missions. But there's also these pioneers and CubeSats. So that's a new line of missions that astrophysics has been putting up. And so they're CubeSats or small sats. I'll let you read those off. I think the next one to be launched is Pandora this fall. So that's the current fleet of astrophysics missions. And just to show off a little bit, here's the pictures from the launch of SphereX, which just took place just this spring. I was lucky enough to happen to be in the area, so I was actually standing. Which hotel was it? The Westin. And from the balcony there, I could actually see the little glowing dot coming up from the Vandenberg. And see, so if there are launches from Vandenberg and you're local, you probably all know this actually, that you can see launches from out of Vandenberg. Yeah, so I wasn't actually at the launch, but I could actually see it go up, which was pretty cool. And so that has been taking data. And in fact, the first mission data release just happened earlier this month. Here's a pretty picture showing, so the SphereX is basically an infrared spectroscopic survey of the sky. And so it's going to map the whole sky and do spectroscopy in the infrared, which is why I can see these, pretty colors in this image. And so that's the Vela Molecular Ridge, and part of this first public data release. The other thing that's really exciting is seeing the Roman Space Telescope take shape. So if you have a chance to go to Goddard in the next few weeks, go to their giant clean room, and you can still see bits of Roman being assembled before launch. But the opportunity to actually see it is closing because it's due to launch just next year. So, so as early as October 2026. Yeah, that's been really exciting seeing that coming together. And just a little bit about Roman's 3 core surveys. I think the thing of most interest to this group in exoplanets is the time domain survey in the galactic bulge, because that's going to produce a lot of microlensing exoplanets. Okay. So I told you I was going to tell you what a program scientist does. So what do I do? So I do a number of things. So actually, I do know, I have wear a number of hats, as I like to say, and I do and have done a whole number of these things. So one of the things we do is we manage research analysis programs. So these are our grant programs. So as a member of the community, you might be interested in proposing for funding from NASA. You would apply to an RNA program, research and analysis. And we love to call these by our acronyms. So there's ADAP and ATP and APRA and XRP, and each are different things. And I'm happy to explain what those are. What's most of interest to this crowd is probably XRP. That's the Exoplanets Research Program. Another thing we do is oversee mission development, implementation, and operation, ranging all the way from the smallest CubeSats to Explorers missions, all the way to flagships. And so, for every mission that we launch in astrophysics, there is a headquarters program scientist who's in charge of, overseeing the science operations of that and making sure that, the science operations are going well. If it's in development, making sure that, they're building to requirements. And I'll tell you a little bit more about the kinds of things I do in particular and later. So there's a bunch of strategic planning we might do. So there's like responding to the decadal survey or thinking about how should we redesign our programs for the future, or if there's a SMEX call coming out, how do we word that? SMEX is small explorers. So it's not an acronym, it's an abbreviation for small explorers. We also communicate with PIs and proposers. So, if you have questions about any of the things that I work on, every grant program has a program officer who's in charge of it, right? And if you have questions about that program, don't ever hesitate to reach out to that program officer, because that's part of our job, is working with the community to help people propose to our programs. We implement NASA policies, and a lot of what I do, frankly, is I mentioned spreadsheets. So there's a lot of accounting going on, right? I have a certain budget for this program. How am I going to allocate those dollars, and making sure those dollars get out the door to our grantees? So what are my current jobs? So I am program scientist for a telescope called the James Webb Space Telescope. Ariel is a ESA mission. I'm program scientist for that. And so that's a mission that's under development. And so here's an example where I am program scientist for an operating mission and for a mission in development, right? And so with JWST, that's making sure that the science operations are going well. For Ariel, that's, again, making sure that the science requirements are being met as the mission is constructed. I'm also program scientist for the Exoplanet Exploration Program. So that's one of those three big science themes that I showed you before. I have also been program scientist for TESS, the Transiting Exoplanet Survey Satellite. I have also been program scientist for the Exoplanets Research Program. So if you have questions, general questions about XRP, I can help you with that. But if you have specific questions for this year, I would direct you to the program officer who is currently doing that. I have also been the ExoPAG Executive Secretary, so being the headquarters liaison for the ExoPAG. I've also been a program scientist for the most recent MidX. So that was doing the down select, basically at the completion of their phase A studies. I'm getting to really technical stuff. At the conclusion of the phase A studies, we did a review and did a down select, and I was in charge of that. And I've also been program scientist for something called Future Investigators in Earth and Space Sciences, which, if you're a grad student, is an opportunity for you to get funding from NASA. So what can a program officer do for you? So what we do, we manage review panels. So we have a bunch of proposals come in, we assemble the panels, and we manage that review. We ourselves do not evaluate those proposals, though. So we ask for volunteers from the community to come in and review those proposals. So it's not me reading all these proposals and determining what the strengths and weaknesses are. It's members of your community. I can recommend proposals for selection. So once I get back all the scores from the reviewers, I can look through them and determine which proposals I might recommend for selection. But I don't actually sign that. I'm not the one who actually does the selection. It's actually the selecting official who is responsible for the selection of proposals. I can tell you, if you call me up, I can tell you, and you tell me about your proposal, I can say, okay, that's relevant to this, to the call that I'm in charge of. And if it's not, I can help direct you. Maybe you should try sending your proposal over to this other program. It might be more relevant there. The point is that you can't double dip. You can't send the same proposal to different proposal calls within NASA. So you need to make sure you're sending it to the right home. I can't tell you whether I think it's a good proposal. That's not my job. That's the job of the panel, is to tell me whether it's a one that is worthy of funding. I can also debrief you on your proposal evaluation. You might get back your evaluation. You might say, you know, I don't agree with this evaluation. I think it should have received a different grade, but I can't change your proposal evaluation unilaterally, right? It is not my job to change that. There's a whole process that has gone through. I cannot change your evaluation on my own. Okay, that said, what opportunities, let's get into these opportunities. This is what you're here for. How do I get funding from NASA? So one thing is just to be part of a mission. So join a mission, become a collaborator. There are any number of ways to participate in a mission. You can help write mission proposals. You can analyze data from it. You can work on calibrating the data. You can provide user support. You can write papers, et cetera, et cetera. There are many, many ways that people can become part of a mission and get funding from that mission to do any of these things. But what I'm really here to tell you more about is, and what my colleague Christina Ritchie will tell you about, is how to write a good proposal, right? So when people say that they're writing a proposal for NASA, they're usually talking about, again, the research and analysis or RNA proposals. So there's an omnibus solicitation that's put out every year. It's called ROSES, Research Opportunities in Space and Earth Science. And I had to put this on the slide because I would not have been able to pull that out of my head. ROSES, and it's released on or about Valentine's Day every year. One requirement is you must be at a US institution to receive funding. You do not have to be a US citizen, but you do need to be at a US institution because the funding gets sent to your institution. Now, ROSES 2025 was a bit late this year, but it is out. It is available at that URL, or you can scan this handy dandy QR code to find the solicitations that have been released this year. Here's just a sample of the many solicitations. So it's an omnibus solicitation because it is everything that you can apply to for all of the Science Mission Directorate, right? So that includes earth science, heliophysics, astrophysics, planetary, and biological and physical sciences. And so they're ordered by appendix. So appendix C, so you see C1 through C11 up there, those are all planetary science. The ones that are D are in astrophysics, E is biological and physical sciences, and F is cross-divisional. And so you'll notice that exoplanets, if you can squint, exoplanets is down here in F3, not in D, not in C, because it is cross-divisional. So F are the solicitations that are cross-divisional. Some notes about ROSES 2025. Again, it was released late this year, and I can't emphasize this enough. Read the solicitation carefully. There have been a number of changes in some of the programs this year, and you need to be sure that you understand what the requirements are for the solicitation this year. It's always the case that you should read the solicitation carefully. Make sure you're following directions when you submit a proposal, but it is especially important this year, especially if you've proposed in the past, some things may have changed and you need to make sure you're being responsive to the call. So some examples of changes this year, some programs are skipped this year. For example, ATP, the Astrophysics Theory program, is skipped this year. Some programs still have TBD due dates, right? So if you go back here, the columns over here on the right are due dates. And there's a bunch of TBDs, in part because the release of ROSES 2025 was kind of a week-to-week thing. We're always being told, soon. Yeah, soon, any day now. And so it was, so because of that uncertainty, Many of these due dates are TBD, which means that you should come back and check again and see when those due dates do get published. And there's mailing lists you can subscribe to be alerted of any of these changes. Some programs have been condensed or consolidated. For example, if you're used to applying to programs within the Planetary Science Division, so anything Appendix C, most of those are now in one omnibus solicitation. Okay, and so just because you don't see your program showing up in Appendix C doesn't mean that program is not being solicited. Read the solicitation, read Appendix C.1 and C.2. And if you have questions, reach out to a program officer. Okay, I want to talk about two specific programs. The first program is Exoplanets Research Program, XRP. So for the most part, if you're doing exoplanet science, this is the solicitation to apply to. It is cross-divisional between astrophysics, planetary sciences, and heliophysics. It is solicited this year, but the due date is different from years past. In years past, the step 1 due date was typically in May. This year, the step 1 due date is in November 25th. There was actually recently an amendment to it because when it was initially put out, it said November 23rd, which is a Sunday. So it was amended to November 25th. If you want to submit a proposal to XRP, the step 1 due date is important because these step 1s are mandatory. Now, step 1 is basically just an abstract, right? So you don't have to submit a full proposal. You just basically submit your proposal summary, and that's what you need to do. The full proposal, so this is your 15-page proposal with all the details and everything, that is due in January, on January 26th, 2026. If you want to see the solicitation, again, there's a great big QR code. I am not the program officer for this program, so if you have specific questions, reach out to John Wisniewski, my colleague there in astrophysics. I also want to highlight for you another cross-divisional program. This is F.5, Future Investigators in NASA, Earth and Space Science and Technology, or FINEST is how we abbreviate that. This is for grad students. Okay, so if you're a postdoc, this is not for you. But if you're a graduate student, this is an opportunity for you to write a proposal for funding. So the FI, Future Investigator, refers to grad students. So these are proposals that are written by the future investigator and submitted by the advisor. Okay, so you should make sure you're working closely with your advisor because they're the one who is going to be submitting the proposal, but the writing is primarily going to be done by the student. This is one of these TBD ones. Okay, so if you read the solicitation, it says this program element may solicit proposals this year, but final details and dates are not yet determined. Okay, so this is one of these stay tuned opportunities. Again, if you have questions, here's an email address you can refer to. Because it's cross-divisional, this mailbox sends emails to all the program officers who are involved with this opportunity. This is another one of these opportunities that's typically put out annually. So, if it's possible that some things will be delayed all the way until the next year. Just stay tuned for opportunities. If you're interested at all in applying to planetary science, so any of those Appendix C opportunities, there is going to be a town hall to roll out the opportunities there and explain more to you about any changes that have taken place this year compared to years past. And so that's on July 29th. That's what, a week and change from today at 12:30 p.m. Eastern. If you want more information, I invite you to go to the link with that QR code there. Again, if you have questions, about anything, there's always going to be a program officer to reach out to. Here is Kathleen Vanderkaden, who is Director of Research Programs in Planetary. Now, what you really want to know probably is how can I learn to write a successful proposal? And my first answer is going to be listen to the talk after the break by Christina Ritchie. But the other thing you can do, and this is where, inviting you, is to serve on a review panel. Okay, and this is where I'm kind of being a little self-serving because I always need to recruit people to serve on review panels all the time. But it is, in fact, quite a valuable experience. I learned so much from serving on review panels. It's how I learned to become a successful proposer when I was at the University of Wyoming. If you're a grad student, you can still be on a panel and serve as an executive secretary. So this means that you're taking notes for the panel. You're not doing evaluations or voting or anything, but you are learning a lot just by listening to discussions in the room. Once you finish your PhD, you can serve as a full panel member. So if there are any postdocs in the room, you should consider serving on a review panel. How do you do it? I was going to put a QR code up here, and I failed to. You can sign up to be a panel reviewer at this website here, or even better, if there's a particular program you're interested in applying for, reach out to that program officer. And if you're not applying this year, say, hey, I'm interested in learning more about your program. Could I be a reviewer for the next time that you do a review? In the interest of time, I'm not going to go through all these things about, why it's great to be on a review panel. I just encourage you to do so. There's also a number of ways that you can stay connected. So that NSPIRE's mailing list at the top. You should all, if you're at all interested in proposing to Rose's program, you should subscribe to that mailing list because it'll send you emails when Rose's gets put out, when amendments are sent out. So if a TBD due date suddenly has a due date, that's where things will be announced. You should also sign up for PAG mailing lists. So of course you should sign up for the ExoPAG mailing list, which is the one in the middle. But if you're interested in either cosmic origins or physics of the cosmos, you can sign up for those newsletters as well. You might also, if you're interested, you can also listen in on meetings of the federal advisory committees that give formal advice to NASA astrophysics. This includes the Committee on Astronomy and Astrophysics, or the CAA. NASAM is the National Academy of Science and Engineering and Medicine. So that's the organization that puts out the decadal surveys that Stephen referred to earlier. And the Astronomy and Astrophysics Advisory Committee, or the AAAC, is also another FACA committee. And that's basically the end of my talk, and I'm happy to, do we have time for questions, Anjali?
Encouraging people to talk to program officers. I'm going to encourage them to use the break.
Right.
So,
and I will be here during the week, so I'll be here all afternoon and also showing up to the workshop later this week. So.
Great. Thanks so much, Hannah. Can we give Hannah an amazing round of applause? And so again, for those of you who said that was sort of over my head, the slides are up there. You can also review Hannah's talk from last year and get more information. But again, I think it's really rare to have a talk where it's like, oh, I as a graduate student or somewhere else in my career can go and do something about this and work with NASA. It doesn't just have to be something off in the corner, is pretty exciting. And again, for those of you who are feeling bleak, like, no, there are opportunities that are out now for funding. So again, I hope you will find this encouraging. We're going to take a brief break. So we'll be back in about 15 minutes. So if you can all head back here at 2:35, that would be great. And then we'll have Christina presenting on tips and tricks for telling your story. Thanks.